Do you want to talk a bit about Luna Lang and do a bit of promotion for that as well? Cool. All right. All right, let's get started. Now I'm gonna switch to the live. Yep. All right, here we go. Boom, we're live. Hey Manuel, thanks for joining the call. This is next Friday, and just to remind the concept, I have Manuel Barnes on the call. He's my student for this call. And today we're going to look into packaging Luna Lang, which looks like a really interesting language. And then we're gonna monitor as well the chat a little bit, so if you have any questions and you're watching the stream, feel free to ask in the chat and we'll try to get back to you. So, Manuel, how are you doing? Yeah, you're welcome. Yeah, it's a big topic. But yeah, let's talk about Luna Lang a little bit first, I guess. Do you want to talk about? Yeah, just. So I pulled up the. Okay, we have a bit of lag, so that's why we're interrupting each other a bit. But just go ahead and I will shut up. Ah,
plain installer for Luna doesn't work on NixOS because it assumes all sorts of binaries to be in some places where they just aren't. And yeah, so I wanted to find out how you can package this. It turns out, of course, somebody already tried that or somebody already started it and got quite far, but not all the way there. Then I forked that project. That project is called Luna Platform, so that tries to pull in the Luna compiler and this IDE, the Luna Studio, pulls it all together and tries to build all of it using Nix. So the original project, Luna, is written in Haskell, and as a build tool, it uses Stack. So for people who don't use Haskell a lot, there are two competing build build tools, and one is Cabal. That's the old style one, but that's and there's Stack. But Cabal is the one that is a bit more compatible with Nix, and Stack seems to be less and less compatible these days. Although I can't really say I'm an expert on how Stack and Nix interoperate.
Yeah.
Well, either way, Luna is written in. So the Luna build is done with Stack, and it's very big, and there's lots of sub packages. So it's not straightforward. It's not as easy as just creating one small Nix file and then calling Cabal to Nix or something and then being happy. But well, that's where it gets fun, I guess.
Yeah, I'm actually before the call we checked out the repository. Sorry, where you started doing the packaging, and it's still building, so it takes a lot of time. People missed the first part of your explanation because the OBS wasn't configured properly. Yeah, basically, you were talking about the motivation about why you wanted to try Luna, I think. But that's okay.
Yeah, just a moment. I'll be happy to repeat it, but I need to connect my headphones because they're low on battery.
So, all good engineers should have a notebook where they take notes. So we have this HackMD document, and we're going to use this to keep track of what we're doing, what we've learned. And I think the first thing to do would be to take a look at the existing packaging and start to dive in and learn a bit more about what we need to do. Another thing is I haven't done much Haskell packaging, and I know the Haskell ecosystem is quite complex, so we'll see how it goes. So this is the Luna platform repo. I checked it out from github.com/turin/luna-platform, and let's dive in to see what's been built here already. There's a README, so let's have a look. This aims to build the essential parts of LunaLang. Help is needed to make this work. Okay. If you'd like to see Luna added to Nix packages, have a look here. There's an issue that's opened. Okay, sounds good. So that doesn't contain more information, I think. And then to build the current work in progress and run this command. Okay. So if we look at the default.nix, right, it's already pretty complicated. So what do we have? That's a big function. On the top we have a number of arguments with default values. So if we just code nix build, it's gonna fill these values. And then we have an overlay for Haskell that changes the existing. So in Nix packages, there is a Haskell attribute that contains all the Haskell package sets, and this is overriding it with its own overlay. Okay.
Does overlay mean anything specific, or is it just a word? Sometimes I'm not sure whether something is an existing concept or whether it's just a good word that describes something.
So in the, I don't know if it exists outside of the Nix ecosystem. In the Nix ecosystem, an overlay is a function that takes self and super as arguments. And self and super are two different. So this is. I need to introduce. So there's a term called fixed points. I assume you're familiar with this.
Mm-hmm.
As a because you told me you're a Haskeller, so you probably know what it means. Other people that don't know about it, it's a recursive function that keeps applying itself until it finds a result, and it's typically used in languages that are lazily evaluated, like Haskell, and Nix is also lazily evaluated. And what happens is an overlay is just one of the layers, and what you can do is create a number of layers, and then the fixed point is going to recurse through these layers and apply the changes. And so, for example, here we see super. Super means access the parent layer. So it takes, for example, the parent layer and then gets the Haskell definition from that layer, and then applies its own definition on top. And so this whole thing is a mechanism to create extensible things. So, for example, you can take the existing Nix packages and then change. Not only you can add new packages to the existing new packages and get a new Nix packages that's all the old packages plus your own, but the other interesting attribute of this is that if you override an existing attribute, for example, let's say you need Haskell, I don't know, GCC 8 or 8.8 or something, and you set the attribute GCC to GCC 8.8. Now, all the packages that depend on GCC and take this as an input to their build inputs, they're going to be affected by the new version that you provided. So not only it allows you to extend, but you can also override things. So that's a quite nice attribute, because you can say, hey, I want exactly Nix packages, but I actually want to change the version of this and this package. And transparently, all the packages that depend on that package are gonna be rebuilt. And you don't need to go and reopen each and every package and inject the new version into it. The downside is that if you change something like GCC, then you end up rebuilding everything.
Yeah, maybe that's the reason why the build took so long, or one of the reasons why the build is still not done, because it changes some things about what Haskell packages are supplied, and that seems to be a big thing.
And so here, for example, it's replacing the Haskell package sets. So that means if you take other packages, like let's say you need Alex or some other I don't know, Cabal or Stack or any of the packages that are part of this package set, and you pull them, then they're going to be rebuilt with the new version. But I'm not entirely convinced that in this case we actually need to replace the Haskell package set. So we could change, instead of saying Haskell here, we could name it maybe Luna Haskell, and then that would create a second package set that's composed of the parent package sets, but it's not going to override it. So at the end you are going to have both the Haskell and the Luna Haskell package sets. I think most of the time that's what you want to have, but it's really like you need to think about, do you want to create a new version of Nix packages, or do you just want to compose your own thing on your site, basically?
One reason I could think of why, in this case, we would want to overwrite the existing Haskell packages, is because it seems that Luna brings a lot of its own packages with itself, like utility packages that are also on Hackage, but somehow the Luna development is not in sync with the Hackage versions. So yeah, it's a quite messy approach to how they do some of their packaging, but it seems like when you go on one of their projects like Luna Manager or Luna Studio, and then you go deeper into the project, then you find that there's lots of dependencies they have that are actually somewhere on Hackage, but they don't use the Hackage version, but they use some version that they supply themselves somewhere deeper in the repository.
Yeah. I mean, it's quite common for programs to do that, I think. Like, if you're a Python developer, you generally have your own set of dependencies that are completely distinct from any other projects, right?
Right, yeah, true. So, okay, that's then maybe my first question. How do we deal with that kind of situation when packaging for Nix packages?
So, another thing I just want to touch on is there's actually three different ways of approaching packaging, which are not going to be the same when you package for Nix packages, or you package to just build your own projects. For example, inside of a company, you might have a product that you just want to build internally. And then there's when you're developing on a project, and you can use Nix to do these three things, but I think the angle changes this a little bit, and I'm just gonna touch over that. So when you package for Nix packages, what you want is to produce an output at the end, and you don't necessarily care about rebuilds and things like that, because you want the evaluation of Nix packages to be fast. And what we end up doing, for example, for Rust or Go, is create just a hash of all the dependencies and sorry, I just need to... The difference is when you're developing, right, you're changing your projects a lot, and you want to minimize the rebuild. And so what you want to do is have each of the dependencies to be in its own derivation, so that when you do a rebuild, if you change, for example, the dependency set, it's just going to rebuild the new dependencies that you introduced, but not the whole dependency set. If you go even further, is if you want to use Nix as a build system for your project, you might want to cut the dependencies or like the derivation to even smaller parts, so that each Haskell module might be rebuilt in its own little derivation, so that when you change the source tree, it's just gonna rebuild the parts that are affected, right? When you package for Nix packages, what you want is just to send this to Hydra and let it rebuild, and it doesn't matter that much. Does that make sense, what I'm saying?
Yeah, it makes sense. But aren't these approaches then compatible in some sense? So when I have very modular, when I have lots of different default .nix for every package or for every sub package of my whole project, that would be the best setup for me as a developer. But that I can still incorporate this approach when I then give back this project to Nix packages when I want to integrate it with Nix packages. Right? They would still be happy if I've written all my Nix files in a very modular fashion, right?
Yeah, I mean, I think it's okay, and we definitely have some packages that are built with this modular fashion. But because we have lots of packages, I think over time we probably don't want to do that as much. But that's sort of an open topic. I think if you ask different people in the community, they're not going to agree on that exactly. Because they have this idea that you can share dependencies between different projects. Like if you build two packages, then you might want to share a common dependency build between those two. But in practice, if you have binaries in the end, then as a user, you don't really care about that optimization because the dependency are going to be mixed into the binary. So you're not really benefiting from that, but you're going to spend more time evaluating all the dependency tree just to get the package that you're interested in, right? Maybe it's a bit of a too fine-grained concern, like. But so I just want to mention a project from my friend Nicolas Mathieu. It's called Snack, and this is a tool that's going or the other end where you want to do incremental builds using Haskell as for Haskell and using Nix as the build system. So this would replace Cabal or Stack basically.
Wow. Can you post a link to that? I've never heard about this project.
Yep. So I'm just gonna post it in the chat. So this would each, I don't know exactly the detail of the implementation, but my understanding is that each module in your source code would be a little derivation. But that's if you're building your own project, then if you want to package an existing project, what you want to look at is what tool did they use and then use the Nix equivalent, for example. There's a Stack to Nix tool, I think. So I'm just talking like overview. In the Haskell world, you have lots of packaging. You also have Haskell.Nix. This one. And there's the good old Cabal to Nix. So yeah, we have lots of tools for Haskell packaging. And maybe another thing is if you go on nixos.org/nixpackages/manual, this just in a general fashion, if you want to package for a language, you're going to search for that language, and there's usually a section that describes how you do packaging for that language in the Nix packages.
With Haskell, I find it quite confusing, to be honest, because there's so many different approaches how to integrate Haskell with Nix.
Mm-hmm.
So there's just Nix packages dot Haskell packages, which seems to me sort of the normal thing or the preferred way of doing something. But then there's Stack, and some projects build with Stack, some don't. And there's what you've just posted.
Yeah.
Haskell.nix, but there's Haskell.nix isn't the one you posted. That's not the only proposal on how to do that, right? There's other proposals as well. I think there's one by Gabriel Gonzalez.
Oh yeah, I'm probably missing a few actually. If anyone listening knows about other solution, then feel free to post to the chat. I think also one problem with, so Haskell has a special part in the Next ecosystem because I think there's a big the people who likes functional programming are naturally going to be more interested in Next than other developers. So there's more involvement, and actually at some point, I think the size of Next packages doubled because Petty added all the packages from the Haskell ecosystem in Next packages. Yeah. And another thing is that because Haskell actually takes a long time to build all the packages, there's a tendency to want to reuse the dependencies that are already in Next packages, right? But in other languages, it doesn't matter that much. Like if you're a Python programmer, it doesn't take much to compile Python modules, right? Unless there's maybe a C dependency or something like that. So that's why I think you're going to see things like we're seeing here, where we're trying to reuse the existing Haskell package set. But it's probably easier to just build your own package set that is the dependency set that you're using for your project. So let's see if it's built. No, still building. And I have 8 cores, so I don't know. It's not the slowest machine.
Maybe we can have a look through the different directories and try to make sense of what is there so far.
Mm-hmm.
And I need to add that most of the code isn't actually my code, but as I said, I forked this approach of trying to package all of Luna.
Mm-hmm.
So these are some of the parts that I didn't write, where I actually don't really understand too well why this choice was made and not another. So if you have anything to say why something is a good idea or not, then I'd be really interested to hear.
Yeah. I wanted to add just something that came to mind is that Cabal to Nix is really good tool, but it's really made for Nix packages, so it's going to inject, for example, the names. It's going to have a mapping between the names of C dependencies and Nix packages attribute sets. So using it outside of Nix packages doesn't make that much sense. And also, the Haskell package set has its own overlay, so you have like a fixed point in a fixed point, and that also makes the whole thing much more complicated.
Mm-hmm. Right. So are you saying that if I just personally build my own Haskell project with Nix, then I shouldn't use Cabal to Nix, or did I misunderstand that?
Yeah, I think either you start your project and you figure out. So one way that's quite successful is if you start your project from scratch, you just say, okay, I'm gonna take these libraries from Nix packages and that's it. But as soon as you have more needs than that, then you probably want to not use Cabal to Nix or any of the Haskell packages that are in Nix packages. But yeah, let's have a look in there to see what's happening. So it's using GCC 8.4. I don't know if it's a hard dependency. It's doing a bunch of overrides. So here it's already quite complicated because we have the double overlay that I mentioned. And now what it's returning is this. Okay. The rec here is not required. Or maybe I misunderstood. But I think we can just return the attribute set like that. Do you understand what I just did?
Yeah, so there was a recursive definition, but since it didn't use this in the body of the definition, you said you can just leave it out,
Yeah, actually,
which
yeah, I did
makes
two
sense to
things.
me.
Like we can just do this, so we don't need the this. And then the rec keyword means that rec is useful when you want to define the keys here to be also in a new scope. But since we're not reusing those, we don't need the rec keyword as well.
So misunderstood rec, because coming from Haskell, I thought that it's about defining something recursively, as
Oh,
in.
no.
Okay.
So rec keyword is when you set it, it's always on an attribute set. And if you put this, then any variable that's defined here, like name equal foo,
Yeah.
this is also going to bind. So it creates a new scope, or in Nix all the scopes are inherited, so it extends the existing scope with a new scope, which is going to have the name variable name. So name is the name of the variable, and it's going to be bound to the value x66. Which means that, for example, typically what you have is something like name is the p name and the version. So it allows you to do something like this. Because now p name is also a variable in the new scope.
What exactly is the new scope here?
So if you don't,
because they are all within the same curly brackets right now, right?
Yeah. So if you just put if you remove the rec, then these key attributes are not. These keys are not going to be bound as variable names. So here it's
so they're just part of that attribute set.
Right.
Okay.
So here it would fail. Let's say I don't know about pname and version. I don't know what variable these are.
So in what scope do we need for I don't know what the name is of this dollar curly brace opens curly brace closes construction? Which variables are available in that scope? So in general.
Okay, so without the rec keyword, this is going to inherit from the parent scope. And here we created a new scope with the let binding. So that's one scope. And then the function itself is going to bind all the arguments into a scope as well. And then on the top level you have the globals, like the built-ins and some default scope that exists in all of the Nix expression language.
Okay, so down there I could, for example, write, even if it doesn't make any sense, I don't know, Nix packages or Haskell lib or something, or GHC, because that's defined in the big let block.
Right, exactly.
Okay.
And the inherit is a special keyword that basically says the GHC key is going to be the GHC variable that's inherited from the parent scope.
Yeah.
So this, that's it. Alright, let's, should we keep exploring a bit?
Yes.
So what do we have here? Okay. So that's a typical construct that you use to pin the version of Nix packages.
I wonder why is it a JSON here? Couldn't we also just write all these as an attribute set in Nix, or what are the advantages to writing it as a JSON?
There's some tools that can produce that output, and it's more because you treat it like data. So, I mean, JSON is a good data interchange format. Or, I mean, some people are gonna argue if it's good, but at least it's understood by a lot of tooling, right?
Yeah.
So what we do here actually is a bit messy. We import Nix packages. So that's the one that's coming from the Nix path. So that's going to be your system Nix packages. And we instantiate the fetch from GitHub function from your Nix packages. And then we use this to fetch the source of the version of Nix packages that we want. And then we call it, and that's gonna give us it's gonna download the source first, and then once we have it, we import it. So now we have the version of Nix packages that we want. And there's actually a shortcut here that says, if Nix supports the fetch tarball, which is in the most Nix versions, then it's gonna create its own fetcher that's going to be evaluated at evaluation time. So, sorry, I'm kind of unwrapping a lot of things here. So we create our own version of fetch from GitHub, either if the next version that we have supports fetch tarball function, then we're going to implement our own version. Otherwise, we import the one from Nix packages.
Why would we do that? Why don't we just use the built-in one or the one from Nix packages straight ahead?
Good question. So the Nix packages, evaluating Nix packages is slow. I mean, it takes maybe up to 1 second on a machine to evaluate. So you want to evaluate only one time if you can, right? So here we would evaluate 2 times. So, and also the implementation is going to vary depending on the version of Nix packages that you have on your system, so it's a bit less reproducible. The fetch tarball one is built-in, so it comes with Nix and happens at evaluation time. So Nix, you really have 2 phases, right? You have Nix, the language that evaluates, and it produces a bunch of DRV file in the Nix store. And then there's a term called realize that takes the DRV and builds them in a sandbox and restores the output in the Nix store. And so you really have these 2 phases. You have evaluation, and then once that's done, then you build everything. So you have like a static build plan. Once you have the static build plan, you build everything. So that the difference is the fetch tarball happens at the first stage, and the fetch from GitHub is actually a build, so it happens at the later stage.
Okay.
And it means that if you do an import from the later stage, what happens is you start mixing both the first stage and the second stage, because for the first stage to finish, it needs to build the source, and then so it's gonna have to switch to the second stage, build the source, and then you can import it back into the evaluator, right? So it changes the dynamic, because you don't have the simple I'm building all the plan and then I'm preparing the plan and then I'm building it. Now you have I evaluate a bit, then I import, then I keep evaluating. And so that technique is called actually import from derivation, because the plans are the build things are called derivation in Nix, and you import from the output of that derivation. And that's something that's disallowed in Nix packages, for example.
Yes, makes sense to disallow it, but then wouldn't it be better for developers, for example, if fetch from GitHub would be part of Nix itself, so that we don't need Nix packages or to get just this function, or we don't have to write it ourselves?
Yeah, I guess so. I mean, the more you bring into the language, the more it becomes complicated. So it's a kind of trade-off that you have to do.
Yeah.
Alright, so that's the pinning, and then in the Haskell overlays, I guess we have
So I think this version is mainly about choosing GHC versions. So the actual Luna packaging part comes in the topmost default Nix. But there's also lots of stuff that I don't really understand that works in how it works.
Yeah. For now, I don't really understand either, but let's keep digging. I see a mention of GHC.js, which probably going to make things even more complicated.
Yes. Because when something builds on GHC 8.4, then your chances are that it will build on 8.6 as well, and probably on 8.8 as well.
Mm-hmm.
But then when you go to GHC.js, then suddenly a lot of things might not build anymore for all sorts of reasons.
Yeah. So here there's a any8 thing. There's any8. Oh my god. Okay, so that's the Luna specific packages, I guess.
Yeah.
So here it fetches from luna.json. Yeah. So you see here you need a revision because the next you want to pin everything, right? So you need the specific git SHA, and then we also have the SHA of the whole archive. And so producing these things can be quite tedious, so that's why you want tooling that automates that for you. And I guess the original author had a tool to do that for Git repos or something.
Mm-hmm. So there was a tool where you could just give it a commit and it would create that this JSON file. And
yeah, so this you can do Nix prefetch. So by default you only have Nix prefetch URL, but if you do Nix run Nix prefetch git, I'm just gonna take the version from Nexus 1909. So now you have this Nix prefetch git, and you pass it URL, and then that should give me, yeah, there you go. Like that's one of the ways to generate that type of JSON.
oh wow, that's useful. Okay.
There's a bunch of fetcher projects, and if you go in Nix packages, this is still building. So in packages builders, I think that's all of the fetchers you can see. So that's on the Nix side, and then if you look in top level all packages and you look for Nix prefetch, there's a bunch of these tools, right? Like there's a Nix prefetch scripts that has a bunch of those. Nix prefetch GitHub, There's another called next prefetch, next bin. There's lots of concurrent experiments, I guess. Like there's no stable tool to do that, but yeah.
Okay. So far, I would always just write my .next file and then run it, and then it would complain about some hash not being right, and then it would tell me which hash it should be, and then I would just paste that in. But I guess then it would be much better as a workflow to use these prefetch tools, and it would tell me what the hash is, and can do it right from the beginning.
Yeah, I mean, because it's a fixed output derivation, if you put a hash that's already in the store, it's just gonna pretend that that's the right version, right? So if you don't use these tooling, you can end up in situations where you change the version of the package, but if you don't update the hash, and then you recompile, you're going to think you're building the new version, but you're still using the source from the old version, and then that can be confusing.
Ah. Okay, so maybe, yeah, I had some problems that sound a bit like this, so maybe that was one thing I was doing wrong.
Yeah, I don't really understand what's all of this.
Well, there are two helper functions, F and G, and I think they're just saying, well, go into that subdirectory of this big Luna repo and build the thing that is inside there. That's as far as I understand it.
All right. Yeah,
So
they built the. So we have two things, right? Luna SRC, and then Luna Studio SRC.
Yes, and Luna SRC should correspond to everything that's just the language and the compiler, and Luna Studio should be everything that corresponds to the IDE.
Okay. And there are two different repositories.
Yeah. Well, it's not just those. There's lots more repositories. In fact, there's also one repository. It's called Luna Manager. That's not something that is being packaged here, but it also exists, and that is at least from upstream, the preferred or recommended way to install Luna. They say, well, just get this Luna Manager binary here, put it somewhere in your computer, and it will install everything from Luna. But then, of course, the prepackaged binary doesn't work on NixOS because it assumes certain paths to be in certain places. And I guess there might be a way around that with using PatchElf and these kind of tools, but I don't understand that well enough, and I couldn't get that to work. So I don't know. That's maybe the big question. Is it what do we do if a language already brings its own tool set like this and wants us to use their package manager, but we will actually want to package everything with Nix, I guess. So there's a bit of a tension here, and I don't know what the best option is.
Yeah. So packaging for Nix is definitely fighting against the impurities of the world. So you're a bit like a white knight, and when you see like some curling happening in the middle of Makefile, then you have to patch it, and hopefully you're gonna notify upstream, maybe don't do that, or provide another solution. And when you're packaging things, like we see here, it's actually really complicated. Like this, I don't think anyone normal should have to handle all of this complexity, to be honest. And So at some point you're like, okay, I spent maybe 3 days on packaging all of this and it's still not working. And maybe at that point you want to revert to the Haki solution, which is to download the pre-built binaries and then patching them for it to work for you. So we could try that if you want. It's probably, yeah, I think we should look at, let's make a little plan. So I don't think we can, during this stream, finish this work because it's really hairy and I think it requires to, be in a kind of focus mode and just load all of the context, and it's going to be difficult to achieve that just right now. So I think we should try to look at upstream and see if there's any easy packaging solution that we can find, maybe using Stack2Nix or something like that, instead of trying to reuse the packages from Nix packages like it's happening here. Because the other problem with this approach is as soon as upstream upgrades their package dependencies, then we're going to be stuck in redoing all of that again. And then we can also try the Haki approach, or maybe we should even try and start with that and get something running. I don't know, what you think?
So ideally, I would like to do this in the, I'd say in the most beautiful or recommended way, because I want to learn best practices as well.
Mm-hmm.
So I guess a lot of things are possible if you know how they work and so on. But what I'm often missing in the Nix world is some guidance on what is actually a recommended way. When some people, don't know, for example, I installed NixOS on my computer using some channel, and then using the 1709 channel or something, and then somebody told me, oh, you should actually use NixOS unstable because it's rolling release. And then I talked to people doing DevOps with Nix, and they tell me, oh, don't use channels at all. It's maybe there's some good guidance on how we do things in a way that won't so I won't shoot myself in the knee later, and that work and that provides some insight.
Yeah.
Even if it's more work.
Okay. Yeah, I mean, the problem and the good part of the Nix is very composable, right? So you can take projects from one side, put them with projects from the other side. But also it means that there's rarely a really blessed solution because you can do all of these things. So
yeah,
that's one of the reasons for doing this stream, is just to teach people how to learn how everything works so that they can do the things by themselves. And then you have to find the balance between things, because we're trying to be as pure as possible, but sometimes you just need to get the work done and you don't have the time to do it, and I mean, yeah, it's like the channels, right? Like, channels are impure because you can update them at any time, and so they're not completely reproducible. So you might not use them, but then it's a good default because it lets you just get started. Okay, so
yeah, makes sense.
Let's have a look at upstream and see, the projects, how they're composed. I think there was a GitHub link, yeah. So that's the Luna project. So we have a stack.yaml. Oh, there's a new... Did you see that already? They're saying development has moved to Enzo, which is the 2.0 version of Luna. Did I lose you? Yep, I did. So what since Manuel is been having connectivity issues, anyone in the chat has some comments? I think we're just gonna look at the project a bit more. Black Quasar security.pam.services.name enable GNOME keyring. What does the name mean and how can I get the possible values here? Right, so the name is it basically means that you can create new services under the PAM security.pam.services attribute set, and so let's see. This option defines PAM services. Okay. So you have a bunch of PAM programs that are defined.
Can you hear me?
Oh, you're back.
Yes, I'm back. Sorry, after my headphone went out of battery, my computer also battery was completely empty.
No problem.
I didn't notice. So yeah, but now I have a power cord and should be fine again.
Okay.
So
yeah, no problem. I was just someone on this stream was asking in the chat was asking me about another question, so I'm just gonna answer that quickly. So Black Quasar, you can see, for example, the KDE has their own prefix, right? So depending on your desktop manager, I guess, you can set enable GNOME keyring. So it would be something like security PAM.services that I don't know what window manager you use, but I guess if you enable the GNOME desktop manager, this is going to be set for you. And actually yeah, here. So the login keyring is set over here. And this is gonna be set if you enable this services.gnome 3. So if you set this to true, that's gonna set the value that you want. Alright, so I was looking into the packaging here, and I think we should try and just package the Luna thing before doing the whole studio.
yeah, that's a good idea.
So let's take your projects. gonna cancel that. Actually, let's take the Luna project. Okay. I have this little H utility to check out stuff on my machine. Before you dropped, I've just seen that they are developing a new thing called Enzo. I don't know if you've heard of it or if you know about this.
Yeah, I just noticed today when we started the stream. So that didn't exist back then when I tried to package it, but I'm not sure how much impact that has on what we want to do. So if we want to start from scratch, we can also try to start from scratch completely and try to package this Enso thing. So Enso seems to be the like Luna 2.0 basically.
Yeah. So Enso is gonna be much easier to package actually.
Oh, okay. Well
Because
then,
it's written in Rust, it seems, and Rust has pretty good support in Nix packages. So so I mentioned my friend Nicolas Mathieu. He's been doing some really cool stuff. He built this tool called Nairsk, which is a way to package cargo projects easily. So we're just gonna use that, and we're just also going to use another of his projects, which is called Niv, which is used to pull in dependencies, and then we're gonna pull everything together. So I'm just gonna create a new branch in here. Then use Niv to set up the branch. Niv is gonna be pinning Nix packages for us. And I think we're gonna use 1909. So here I'm showing you how to package the project like if it was yours, right? So Niv created these two files, and the interesting one is the source.json, where it puts Niv, which we don't really need right now, and Nix packages. And we're going to create a default.nix here. And basically what it gives you is you import the Nix equivalent, and then here you have access to, for example, source.nix packages, which is the bin version. Okay, so that's...
So I can basically use that to pin Nix packages on some current version right now.
Yeah, exactly. So right now we have this default.nix, and we have access to Nix packages. So for example, we can build the hello package.
Okay.
So that's kind of a way to... imagine that's your project, you would just start with that. So now we have the bootstrap. Okay. Now we want to use Nairsk because the nice thing about Nairsk is that it's a Nix. It's a bunch of Nix code that allows you to read the cargo.log file and automatically produce the derivations, so you don't have an intermediate cargo to Nix step or something like that, which is also pretty useful during development.
How does it produce a derivation if it doesn't create some Nix expression?
So that's the beauty of cargo, and it's so when you do cargo. Oh, I don't have cargo. Actually, this project doesn't ship with a log file, but basically the idea of Narusk is that it's going to read the log file. And the nice thing about Rust is that the log file contains everything that we need to pull the dependencies. So it has the whole dependency tree, including the hashes that are going to be compatible with built-in fetch.url and things like that. So Narusk can just read that file and produce the derivation without accessing the network. Does it make sense, or?
I'm trying to understand completely. So that means that there are different tools that produce derivations. Nix is one of them, and Narusk is another one. Or does Narusk use Nix at some point?
Yeah, Narusk is a Nix library.
Okay. I guess what I don't really understand is how this is any different from, let's say, Cabal to Nix. So Cabal to Nix, as far as I understand, takes a Cabal file and outputs a Nix file, and then you can build this Nix file.
Mm-hmm.
And you get a derivation.
Yeah. So do you remember I mentioned this import from derivation thing? So
right.
If you do, sorry, I'm just trying to explain this how it makes sense. If you do a bunch of impure stuff, right? Like, let's say you need to talk to all Cabal hashes, you need to fetch it, and then compose this with your Cabal file, and resolve the dependencies, and then you can produce a Nix file. Then you need a step that has unfettered access to the network, right?
Mm-hmm.
So you need to run this tool outside of Nix, because Nix only allows you predetermined inputs. Right?
If I have Cabal to Nix, for example, it will tell me, use some Haskell package foo, but it won't tell me use. That can't tell me whether I already have some specific version of foo in store.
Mm-hmm. Yeah, exactly. So it's going to have to talk to the network and resolve that dependency somehow, right?
Yeah. And that's going to choose a very particular version, and after it's consulted, don't know, probably Stackage or something.
Mm-hmm.
And
depending on the constraints bounds that you have on some dependencies, the resolved version is going to change over time. Because maybe a week later there's a new version of the dependency that's been released, and the dependency resolver might pick the newest version instead of the oldest, right?
But if I if I use Cabal to Nix, for example, then I basically want to tell it, well, resolve all of the packages with whatever version of the package is in Nix packages.
Mm-hmm.
Wouldn't that work as well? Or, I mean, then it would be deterministic if I pin a particular version of Nix packages.
Yeah, that could work. If you're lucky that all your dependencies are in Nix packages.
Right.
But Nix packages only has like one version of everything. Or at least we try. So it's not gonna build all the versions that are available on Hackett, right?
Yeah.
And so, so what happens is that you have a log file for a lot of languages that records the pinned version of everything. And then often you need a tool that converts that pinned version to a Nix file, right? And so it means that as a developer, if you don't use Nix, it's annoying because now every time you update the log file, you need to update the Nix file, right? So every time you change your Cabal file or something like that, you need to run Cabal to Nix and then check in the Nix file as well.
But I can run Cabal to Nix from inside Nix, right?
So Cabal to Nix has a mode where you can run it from Nix packages as well, from inside Nix, sorry.
Because it's always strange to check in an automatically generated file.
Mm-hmm. You want to avoid that overall, right?
Yeah.
But Cabal, so there's in Nix packages there's a call Cabal to Nix function that exists. But this one is going to use the import from derivation trick that we talked about. Let me draw, maybe if I draw something it's going to be more clear. Thanks for asking all these questions, by the way, it's really nice. I don't know if we're going to get the Luna packaging finished, but if you learned a lot of things, then that's the important part.
I definitely did learn a lot of things so far.
Oh. My writing is terrible. Do you see this on the stream?
Yeah, log file.
Okay, you can even read it. Well done. So somehow we resolve. There's like a dependency requirements, and then we have like registry. And this is going to reduce to a set of, like this is the set of dependencies that we resolve at one point in time. And this is often checked into a file in lots of languages. In Haskell, this is not the case. And the registry is all Haskell packages, I think. There's a Git repo that has all the hashes and versions of all the Haskell packages, and then that's going to be your cargo, your Cabal file. And so once you have the set of dependencies that you need, ideally it's a list that contains like the name and the SHA of the dependency, and then some metadata as well, like dependencies. And then at some point you want to produce some derivations. So you want to map, here we're still in the language sphere, and then here we enter the next world. And that's where we're having the conversation is, how do we get the next stuff? And there's different ways. You can either have like a tool like Cabal to Nix, and that generates the Nix code. Then there's the call Cabal to Nix. My writing is terrible. So this is going to be running inside of a derivation, produce the output in the store, and then we import it, and we have then in the Nix the Nix evaluator or Nix expression language, we have the set. And the last thing I was talking about is a Nix library. So it loads the log file in the Nix language as an expression, and then it produces all the derivations just by mapping over the set and converting it to Nix compatible derivations. So that's the NARSC approach.
So is NARSC completely written in Nix then?
Yes.
Okay, because Cabal to Nix is written in Haskell, so that means Nix doesn't really have a foreign function interface or something to call into other languages, because other languages might be impure. And then instead, if it needs to call into another language, like in Cabal to Nix, it builds the tool as a derivation and then imports the derivation, as you say, and then it can use it. But that requires this extra step of first creating this derivation.
Yeah, exactly.
And that's what NARSC does not have, because it's just written natively in Nix, if you wish. Is that right? Okay.
And for this, that's kind of the ideal scenario, I think, so the NARSC approach. But it requires that everything is aligned so that, for example, the log file contains all the information that Nix would require, so that Nix doesn't have to do impure stuff. Because as soon as you need to do impure stuff, then Nix is out of the weeds.
And it also requires you to write a program in Nix, which is arguably not as nice as writing it in Haskell. Or even writing it in Rust or something else.
Yeah, so I think the implementation here is still fairly decent, but yeah. So let's keep going. So here we produce our little overlay. So the idea is that we have Nix packages plus our own packages, and we need NARSC. Okay. And then so we kind of have our thing, and maybe we create another defaulted Nix on the top. It's gonna load. So here we pretend that this is Nix packages, and I think the format's changed recently. Alright, let's see if it works. Right, it's missing the cargo.log file.
I think you need to run cargo once to generate one, because something needs to do with the dependency management.
Actually, let's add a shell.nix here.
I was about to say, that's really a nice way to run a program without installing it like that. Just something that I noticed. It seems like that this new project is written 1/3 in Rust and 2/3 in Scala. So, I mean, this ENSO project, or even less Rust. There's also Java. Rust, Java, and Scala. I'm a bit surprised because the previous project was completely in Haskell, and I don't know how much this is the same thing that we originally wanted.
Okay, maybe we should look a bit more into the project then. Because, yeah, you're right, there's a build.sbt. So that's Scala packaging. Oh my god. It's even worse. Just gonna steal shell.next from one of my other projects. Okay. Yeah, Black Quasar says this package is so hairy. Alright, so we have some issues with, it depends on OpenSSL. Do you know about Diren for?
No.
It's another tool I wrote a while ago, and it's basically it allows you to load environment fibers dynamically. So now when we enter the ENSO project, it loads the next shell for us automatically. Oh, we need pkg config.
So, why are you now using Cargo to build it from there? Wouldn't it? Why are you doing that and not, let's say, write a Nix file that will build the whole thing and then just repeatedly doing Nix build?
So right now I'm trying to create this log file for us.
Okay, we need that first in order to be able to create Nix file at all. Okay, see.
Now we have some issues with the preload.
Oh, that's surprising.
Any Rust programmers out there?
I actually do Rust programming, but I haven't seen that.
I'm pretty sure this is going to be some nightly Rust stuff, right?
Yeah.
Okay, I'm just gonna steal. I have another project called Nix Packages FMT. This has a. This is one using Nix Rust Unstable. need WASM, and we don't need pre-commits. Alright. Okay. Yeah, we need to, so Mozilla has Rust. Next package is Mozilla. Alright. I think this is also an overlay, so I need to change this and add Mozilla in here.
I must admit, I don't exactly understand anymore what we are doing right now.
We're trying to build a development environment for just getting the Rust unstable.
Okay, so this is just for getting the new versions of standard library and so on.
Yeah, and so we can create a log file and then we can use NARSC to build it.
Okay.
Yeah, I should probably explain what I'm doing a bit more. Just need to look at how everything was stitched together here. Oh, okay. Yeah, we need to import it. This. Okay, so now it's fetching the Rust unstable.
I still couldn't quite figure out which parts of this Enso project are actually written in Rust. And also how it goes together with everything else.
Okay. Yeah, I guess we should take another look.
Because there's also folders like the IDE folder where there's just no code in there. There's just a git keep. Oh
yeah.
There's some tool called Graal, which I haven't heard about, that is being used. Seems like they're just using every tool that exists, every language, and just mix them all together.
Oh, now they're using Graal? So the Graal VM, I guess?
Yes.
Oh no. Yeah, there's some Scala in here. So that's a really difficult project to package because you have different languages and then how they're tied together, it's gonna be custom, I guess.
Maybe it is easier to just go back to the old Haskell project, the old Luna, just the Luna project and nothing else, and just package that. Not sure. Because at least that was just one language.
Yeah.
But yeah, I'm not sure. I hadn't heard about this Enso thing before.
Let's just see if the thing builds, and then we, depending on that, we're gonna switch or not.
Yeah.
Right, it's missing OpenSSL again. Welcome to the world of packaging. So it's working in the sense that it was able to read cargo.lock. But then the build fails because it's depending on OpenSSL, and we need to find a way to inject OpenSSL to the part that actually requires it. And to do that, we would have to look into the implementation of Narsk. I hope I'm not scaring too many people off right now.
Maybe I brought too hard problem for the first time, but well, now we are in it.
Yeah. Yeah, that's definitely not a beginner's topic, I think.
Yeah.
But I wanted to start a stream, and so I didn't plan a lot about, actually teaching things. It would be nice maybe to go back to the basics, like what is a derivation and how to read the next source code and things like that.
Yeah, but it's still very valuable to do this because this shows like the real world problems that we have when using this kind of thing.
Yeah, this is completely unfiltered, or I didn't even really prepare for this call, so that's exactly what you would face if you were a bit experienced and you would try to figure out what's going on. So I don't know, what do you think? Should I keep digging into this, or do you want to go back to the original project? I think
So if there's a way how we can quickly make some progress with Narsk, that would be interesting, I guess.
Yeah, I think I just need to read this source code for a bit, so and then figure out the extension point in here. And once I have that, then we can make progress.
Seems to me that we need to put in some build inputs, and for that Narsk really needs to give us a way how we can add build inputs.
Yeah, so there's a thing called override here that sounds promising.
There's also a built-in, override and build inputs. Wow.
Yeah, I guess we could just try and add the build inputs. So we need OpenSSL and pkgconfig.
Kannst du das Licht anmachen? Danke dir.
Looks like it's working.
Oops, sorry, that was me trying to scroll up.
Yeah, it's Tmax, so I think it's Control B and something like, I don't know Tmax. I know it's Control B and something to enable the scroll mode. Oh, there you go. Now you can go up and down.
So, okay, a question about this. So what we called Nix build, and that calls cargo build, and now actually cargo is doing all of the building and building all of those dependencies in one go. Wouldn't it be better from NixOS perspective to have each of these dependencies already packaged, such that cargo build doesn't even need to do all of that, and we can just get them from the cache and directly build just our own project?
Yeah, for sure. I mean, if you have C dependencies, typically you have one version of it, so it could be pulled from Nix packages directly, which we did here for OpenSSL, for example. The problem is with Cargo or Node projects or Python projects, you don't only... It's a combinatorial problem because, or maybe not combinatorial, but it's definitely the number of combinations that you can have with all the dependencies mean that, for example, let's say you build, this is a tree of dependencies, right? So even if you have the same version of AutoCFG, for example, which is 0.1.7, if in your project AutoCFG has resolved and AutoCFG has a dependency itself, it might resolve to a different dependency version, and so you would end up rebuilding it anyways, right? Maybe let me draw this again.
But then what is the purpose of NARSC then? Because wouldn't it prevent us from doing that because it can pin down the exact version? So I thought NERSC takes this cargo log file, which has the exact versions of every dependency, of every Rust dependency at least, and then produces a Nix file. Produces a Nix expression from that, that could produce a derivation from it. And I don't understand why Cargo needs to build all of these things again, or what we have gained at all.
So what there's, in terms of granularity, you can split things into smaller derivations. What happened here is that Nix fetched the dependencies for us and then provided them to Cargo. And then I'm not sure if each of the Cargo dependencies are compiling separately or not, but I'm not sure about that actually.
Okay, so it fetched us the correct source code?
Yep.
I see.
So you get the benefit that you don't have to generate this Nix file and you don't have the import from derivation. But I don't know, if you go finer grains, and it's definitely possible to build each of the packages as a derivation, then you need to integrate more deeply with the tooling of the language. And so if the tooling changes, you need to be also updating your Nix code so that it maps. So yeah, it's more effort, I think.
So in that case, I would need something that can inject the build package into Cargo and tell Cargo, hey, don't build this. I've already built it and it's there.
Yeah.
And that's much harder than just to say, well, here's the source code.
Yeah, I thought it was the case because basically you need to put things in a specific locations on the file system, right? Even when you prefetch the downloads, then you need to put them in a location that Cargo says, oh, I already downloaded, and then it's not going to try accessing the network. And you would have to do the same for each package. And sometimes some languages have more or less messy separation, like more or less strict separation between the packages. Typically, Node.js packages are allowed to reach out of their installation folder and do some stuff. And so sometimes it's easier to just bundle everything as one derivation. Right. Oh. Oh, because we... So what happened here? Right, so we have the same problem as before, I think, with the Rust nightly. So we need to put in... So we need to tell Nairsk as well to use Rust nightly. So Nairsk takes Cargo and Rust C as the build inputs. So what we can do... Don't need all of that. Let's move this. I think that would give us what we want. And then we inject this. And we want Rust C and Cargo. And because we access it directly, we need the rec to create this variable.
What does inherit with extra argument in brackets mean?
It's like the unpacking bit. So it unpacks the attribute set and sets these two attributes to the parent. So it would be the equivalent of this.
Okay, yeah, I see. So inherit is just really some syntactic sugar for not having to write out a lot of assignments. Okay.
I would actually prefer if we had a way to do it a bit more like the Haskell pattern matching or something.
Record wildcards, yeah.
Yeah, something like... I don't know if it's... Like something like that would be pretty sweet, I think.
Mm-hmm.
Or maybe without the brackets. Something like that.
Yeah.
Because here you end up shifting, so you have the code like that, and then you have to turn it around, right, when you start moving to the inherit. So moving from one style to the other is more work. I don't know if it makes sense.
Yeah, it's really hard to design a good language, I guess.
Yeah.
At the beginning, at some point, you introduce some statement like inherent, and then everybody uses it, and you can't change it anymore because everybody's already using it.
Yeah. Or yeah, you just want to do something quickly and then you're like stuck with it for a long time.
Yeah. Yes, I think I understand better why the documentation for NixOS is not so good. Or I would say the documentation for Nix and NixOS, well, the stuff that exists, all the manuals, for example, they're very high quality and they're great. But I think a lot of people looking for stuff like, how do I do a very simple thing, but in the best way, or something that is next to simple, something like here's a Haskell project. How do I package that? But it needs one extra dependency or something. And well, you've taught me today that there's lots of different ways to do things. Like, do I use Cabal to Nix, or do I do call Cabal to Nix, or do I use Stack to Nix, or is there are different ways to solving the same to solving the same problem? Some with advantages, some with disadvantages, and I guess a good documentation for that would tell you, oh, here are the 5 different ways, and here's the comparison. If you want to achieve this, you better do it like that, and so on. But that's, of course, harder to write big comparisons between all the different emerging ways to solve problems. So I guess why I understand better also why not everything is well documented, because in lots of problems there is no single accepted solution.
Yeah, and also how we saw it requires an interaction between the target language and Nix, and that can also evolve over time. And
Yeah.
and as I explained with the log files, ideally we want to influence these languages to provide us the desired data that we can just source and then use it directly into Nix. So we also want to shape the other languages. And so in some sense, Nix is the universal package manager, but it's also not so good for everything because, yeah, basically each language is evolved in their own little sphere, and yeah.
So I find it strange that now we still have these problems here that
So
it says can't find crate for STD, so that's a bit different. It sounds like NERSC didn't tell us where to put the standard library crate. The STD is like the standard library.
Yeah, it sounds pretty bad. I don't know if it's the Rust distribution that we're using that has a problem. Because the project depends on Rust nightly, I guess, and yeah. Hornet has multiple projects actually.
So maybe there is just no good Rust package in the directory we are just looking at.
Yeah, it's possible. I don't know, I think I would have to take this offline so I can really think properly, but yeah. Yeah, it's a bit of a shame that we don't have anything working right now.
Yeah, True, but to be honest, I would have been absolutely amazed if we would have gotten the whole thing packaged. I would never believe that we would have been able to do that, to be honest, because I'm actually really happy with how much I understand now why it is so hard to
Yeah.
get a big thing like this packaged for all sorts of different reasons. But
Yeah, you're hitting all the impurities of the word, and the style of packaging is just to bang your head against the thing until it works, you know. But the nice thing is once it's packaged, so you, like we see here, it's difficult. You have to learn about how Nix works, how the language works, how the packaging works, etc. But the benefit at the end is that once that's working, then I think NixOS is one of the most reliable systems that I know of. Because once we did all of that work, then everything is, repeatable, reproducible, and then you can start composing it with other things.
Yeah.
But yeah. I think we should take a break, maybe. And I don't know if you want to try the Cabal to Nix version next, or if you want to end there, it's up to you. Otherwise, we can also open the floor to viewers and see if they have any questions or they want to do something else.
Yeah, I would be happy if further people ask questions. So I feel satisfied for now, to be honest, and I'm not sure I can learn much more today because I have a lot to absorb now.
Mm-hmm.
So maybe at some point I'll try and give it a second go and get more grips on the project with everything I've learned now, and then I can come back with a different problem. But for today, I'm pretty satisfied now.
Okay. Cool. I think I kind of wanted to. I was hoping that at the end you would get a sort of roadmap that you could use to continue to work on your own.
Mm-hmm.
So, but I don't have one right now. So, what I propose is after this stream, I'm gonna take some time and look into packaging the version 1, because version 2 seems like it's still very much work in progress, and the goal is to have something that you can use. And then I would provide you with sort of a roadmap of how I would approach it. And also, streaming is nice, but it's sometimes you need deep thinking to align things in your head. So I think I would be able to provide you with something more substantial.
Yeah. Yeah, it's true. Sometimes you have a problem where you really need to think about it for 10 minutes and without having to say anything or without having to do anything in the meantime.
Yeah, last stream it was mostly about explaining things that I know, so it was quite easy. And I'm still learning how to do this streaming thing. And here there's lots to absorb, so it takes like a lot of part of the brain, I think.
Yeah.
Yeah. Cool. Well, thanks for coming anyway, and hopefully we can have another stream where we take this a bit further, or I don't know, maybe we can try something else.
Yeah, well, I always have tons of NixOS issues that I could work on, that I would like to make some progress eventually. So we'll never run out of things to do. And I'm sure lots of other people have very interesting problems as well. So
yeah.
Yeah.
Cool. Just gonna wait. Ask the chat if they want to ask any questions or if they want to see something else happening.
Yeah.
If you want to hang up and go back to your day, it's up to you.
Okay. Well, I'll take this moment to thank you a lot for 2 very intensive hours of getting into a very deep aspects of packaging and looking at some really gritty details. And thanks for enduring with me in this quite hairy package.
Cool. Have a nice day, Manuel.
Yeah, thank you.
And the chat is dead, so I think I'm just gonna hang up as well. Next week we're going to be talking about JavaScript packaging, if you're interested. See you everyone.